硅谷前几年ED 学引发的风波，让人不禁怀疑 ，Ameryz 的癌症检测是否又将引来争议呢？让我们有请丽来给我们解答。
I have always been concerned about cancer. In 2018, about 10 million people died because of cancer. 1 in 2 of us will go on to develop cancer. And about half of those will be diagnosed at late stage. The current detection methods are slow and expensive. Cancer detection is already a challenging process. And to be able to catch cancer at early stages is something really hard to do. Cancer is a complex disease. Ever since young, I have been interested in the cancer pathways. Professor Robert Marks and I have expertise and technical competence in different fields, but we are combining our skill set towards the same mission. We are on a mission to make cancer screening more conventional. We are developing an immunoassay for point-of-care cancer detection. So it's scary to think that 1 in 2 of us here will go on to develop cancer in our lifetime. And for half of those who do, they will find out at late stages, at stages where cancer is hardest to cure. The reason for this is scans are only good at detecting tumors that are larger and more aggressive. What if I tell you that it's possible to detect cancer much earlier, even before the solid tumor develops, just by looking at signals in the bloodstream? The signals that I'm talking about are DNA that are released by dying cancer cells or cancer DNA using this huge sequencing machine. The problem is, this process takes 2 weeks and costs thousands of dollars. That's because every single strand of DNA in your blood sample needs to be read 15,000 times just so we can identify the sequence that belongs to the cancer DNA. And that is why our big vision is to replace this huge sequencing machine with a device that can be used at the point of care. If we know the sequence of the cancer DNA, it's possible to build a probe that has a complementary sequence to fish out this cancer DNA. In order to do that, we are going to use machine learning to identify these mutations by analyzing datasets from thousands of patients. And then we are going to use AI to generate the probe sequence based on the criteria that we specify for. And once the probe is ready, we are going to integrate it with the StackPad technology that has been designed by my co-founder. So this is how the final product will work. A drop of blood is spotted at the bottom of the stack. And this drop of blood may contain cancer DNA and will certainly contain normal DNA. They will migrate up. And if cancer DNA is present, it will interact with the probe, forming this structure. And at this point, the normal DNA will stay free-floating on its own. All of this will continue migrating up until they reach the blocking stack. At the blocking stack, the normal DNA are blocked and can no longer travel up. But if the structure is present, it will continue to the uppermost layer, where an enzymatic reaction will happen, and a colored product will form. So the formation of this colored product indicates the presence of the cancer DNA, and the intensity of the color indicates the concentration of the cancer DNA. So we have done the proof of concept to detect bacteria in water sample. And the final product will look something like this. So why is this important? It's important because our solution is 10 times cheaper and 100 times faster than what's currently out there. And also, our solution is scalable, meaning we can build a probe to target any mutations we want. There is a huge and urgent need for early cancer detection. And as such, we are planning to enter the Chinese market by mid-2021 and the US market by mid-2022. All this will not be possible without a world-class team dedicated to the mission. My co-founder, Professor Robert Marks, is a professor in biosensing and holds several patents in the biosensing area. I have a PhD in pharmacology and have previously co-founded a robotic startup to automate cancer research. The social impact of what we are doing is huge. Having a device that can be used at point of care means doctor could make treatment decision on the spot. A device that's easy to use would mean more people could get access to it. And finally, if we are able to detect cancer earlier, patients would have a much higher chance of survival. Thank you.
Thank you. 我们把掌声送给 Lee. Thank you,
Thank you.
Lee. I think this is so important because sadly, I think everybody's life has been touched by cancer in some way. 那我们进入我们的问答环节，同时提醒一下我们的观众可以开始打分数。Do our judges have any questions?
Yeah, I just wonder what percentage of all the cancer that exists your technology is going to discover?
Yeah, so we have actually completed the proof of concept on bacterial detection. We haven't tested it on cancer DNA yet, but that is going to be something that we're going to do later on.
What do your estimates?
So, it depends on the stages of cancer. So with the current gold standard right now, if you're talking about late stages, the accuracy is about 99%. But if you're talking about early stages, the sensitivity is still around 38% to 60%.
Maybe I wasn't clear. I meant from all the type of cancer that exist, you are not going to detect all of them, or are you?
Yeah.
You're going to detect some of the cancer. So what percentage?
We of course we are not going to target all the mutations because there are around 3 million mutations, and we are going to target the mutations that are well studied, and also it's worthwhile to target mutations that already have drugs for them. So for things that do not have the therapy for them, even if you know that there is a mutation, there's no point, right?
Professor.
Yes, I have a similar question. So, have you evaluated the reliability of your method? Do you have false positives or false negatives? Is my question clear? Yes?
Yeah, so as I said, we haven't tested it on the cancer DNA yet, so we do not know we do not have an idea of the false positive and false negative.
Okay.
尹教授。
你的训练数据从哪儿来？
Where did you get your data for the training?
For the training, yeah, so we're planning to collaborate with biobanks to access their proprietary data set and also their blood samples.
Thank you. 谢谢尹教授的问题。Dr. Bentley.
Hey, we've also met before in London. I should say, presumably there should be more applications than cancer. Of course, cancer is an extremely worthy cause and definitely worth pursuing, but there are many specifically genetically caused diseases, right?
Mm-hmm.
So have you thought of actually targeting some of those?
Yeah, so one of the other applications of this, looking at this cell-free DNA is that, cancer is the most well-studied because they realize that these cancer cells actually release this circulating tumor DNA. But if we are actually able to identify the biomarkers for other diseases as well, then this is also something that we can target. And that was why I said the solution is scalable, because we can build a probe to target anything we want.